Right, welcome back. In my last video I covered the construction of my lower sequencer card, which is here. So basically this will do the cycles from 8, 10 and 12. So basically the finite state machine can run for up to 8, 10 or 12 stages. So now it's time to move on to the upper sequencer card, and on this one a very similar sort of layout. We'll be taking the state machine up to 14 cycles and then onwards to the full 24. So just before, a similar sort of amount of work to do. Going to need to put all the diodes down for each of the relays, and then the diodes just to make sure the pulse signals can't feed back into the FSM stages. LEDs down the front, connectors on the back and down the side here. Now the difference this time is this is the upper card, so actually the connectors for here need to be on the back. And I think the way I'll do this time is actually I'll have some connectors facing like this, so I have them facing that way, because now actually I can solder onto either side of the board, which is quite nice because I'm using PCBs, much easier. Whereas last time, this is the upper card of the old sequencer, I was sort of having to use these here. And what I'll do this time is I can actually do these sockets either side, and I can just have these connectors here just bridge between the two sockets. So basically it'll connect to the socket on one side that way, and then the same on the other side, and that'll just make it a bit easier to handle. Cool. Okay, so I think we've got everything we need. So again, I'll do this as a time lapse, just take through all the soldering. To test this card, I'll need to stack these two together anyway. So this time round, what I'll do is I'll solder the entire card together and then give it a test all in one go. Although I think I will pause at one point just to test the LEDs work, just so then if there's any problem with those I can catch it earlier. Okay, so that's the plan. Let's make a start. Okay, right, so that's the diodes in, and the connectors in, and the LEDs in down at the front. So what I'm going to do now is just give these LEDs a quick test, just make sure they're all in okay. So I've got my bench power supply ready in the background, and this time actually I can actually take the ground from the back here. So if I just flip the card round, the ground plane comes in on the 2 pins here. So effectively if I just take a pinch off of there, and that'll do us quite nicely for this And what I'm going to do again is just go around the board and pick up the S lines that I'm looking for. So for example, if I start at number 13 here, I get a light there. So I'll just switch the power on and start at 13, and there we go, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22 and 23. You notice again that these lights lit up as we're going through, and that's again because some of the pulses are derived directly from these stages, but again I can sort of pick them off straight away from the outputs here. So again, if we go here, that's L, O, oh yes, right, actually, because that's because there's two joined together there, so right, try it again. So L, N, O, Q, R, S and T, and the M actually comes up from the lower card, so that should be M there, even though technically it's part of this card, and that's just because it's just at the cusp of between stage 12 and stage 13. It's basically what makes the M line up. So the last one then is just the abort line. So as before, we had the abort 12, 10 and 8 on the bottom card. Up here then we just need the abort 14 line, which will come over to there. Cool, so that's all the LEDs working as they should do. Just turn the power supply back off again, just move some of these cables. As I mentioned last time, I've put some masking tape onto the onto this faceplate here, because actually it was the LEDs weren't quite holding in place. It's making them very fiddly to insert. But what I can do here is actually, now I've got them in here, I can very gently sort of just push the LEDs out and then let the board come away from them like that. And all the LEDs more or less stay in place. You can see that board basically now is the one with all the tape on the back of it. The problem is when you push through the holes, it makes all this mess on the front. So the most sensible thing to do for that would be for me to get some of my some more of my boards here. So what I'll do is I'll just quickly hold the box up. And basically these are the so because it's a minimum order of 5 units every time, I tend to have a lot of spare boards. So if I just reset the video, there we go. So it's a bit better. Yeah, so this is actually the another 4 copies of the test board that I've got up here. So that's basically that board. And then for each of the other cards, I've got 5 copies of all of them. But also that means I've also got 5 copies of the faceplates as well. So I've got plenty of these spare, because these are actually unique to each of the cards. So in this case is the faceplates I've just been using. So what I can do then is I can take a nice clean one of these out, like so, if I can get hold of it. There we go. So that's another one of those that's just all nice and clean. Also I can look at them as well, see what the holes look like as well, because these holes are all sort of laser cut. So some of them have a bit of burn marks. These ones got quite an ugly burn mark on there. So what I might do is just see how the others compare. Let me open that a bit further. There you go, that's a much nicer one. So I'll go for that one. You can see the difference is quite, I don't know if you can quite see it on the camera there, but yeah, that one's got sort of some burn marks at the side of it. And that's fine, that's I kind of expected that when they were being made. So I shall keep these ones as spares in case they're ever needed, but otherwise they have served their purpose. And then put everything back away. I mean, it is probably more, having 5 boards of each one is probably more than I need, especially as the designs are quite unique. It's always nice to have a spare or 2 available, so maybe I'd have ordered 3 rather than 5, but 5 is the minimum quantity anyway for JLC PCB. To be honest, actually though, I mean each board's coming in probably about £8 or £9 for English pounds for 5. So actually, it's hardly, you know, a £2 a board. It's hardly worth worrying about. Right, so just bring this back into shot. Are we still focused? There we go. Let's bring up the brightness a bit. Right, so I can now take this nice clean board and pop that over these LEDs and then just very carefully inch it on and then just gently push it in so it's over all the LEDs nice and snugly. There we go, that looks pretty good. Now what I'll do is just tuck in the ones that are not quite pushed in as far as I would like. And there we go, that's not looking too bad. So that's really nice and clean now on the front and looks a lot more professional. Cool, right, okay, so it's time to solder in all the relays now, and also I need to solder in the connectors. And again, as I mentioned before, the connectors on this are going on the back. So again, let's jump through that, and then basically we've got a complete card that's ready to test. Right then, here we are again, ready for a test. So you can now see that I've basically stacked the two cards together. That's needed to be able to test the upper card. The upper card can't actually work without a lower card, so that's all basically as it will go into the machine. Right, so it hasn't been totally fuss-free. One thing I did recognise just when I was having a closer look at the soldering was this. So basically this is where actually, just before I've sent the board from manufacturer, I've actually forgotten to rebuild the copper pawl there. So what's happened here is actually I must have moved one of the vias over slightly, and the copper pawl hasn't updated. Now of course that actually means now that line's actually grounding. So what I've had to do is basically go onto the copper track and scratch away the coating, cut through the track, and then basically just wire over it, which you can see here. So it's a bit of a dodgy repair, but basically there's no other alternative really. So I've updated the design on the board again, so if I ever do get another one of these boards, that's okay. But yeah, the 5 boards of this I've got, they're all broken and all the same. So anyway, that aside, we're in a good place to start testing this now, so let's do that now. So setup's very similar to what I did for the lower card on its own. I've got the test board all rigged up here. I've got the button on the right here set up to activate the clock, and I've got the one here set up to do reset. So they're basically coming in through the lower card at the back, just as before. Power now is going to the power connector on the top, and then that's passed down to the lower card through here and here. So that's all great. The other thing then is basically the what's called the operation bus here. I've just brought out to this board here, which will actually come onto this left hand side. And what I'll need there is the 4 connectors at the bottom, so 1, 2, 3 and 4, and basically that will relate to the abort 8 signal, abort 10 signal, abort 12 and abort 14. Right, so let's first of all just test it going first on the sequencer. So what we'll do is we'll take the sequencer all the way up to 24, up to the 23rd item, so 24 cycle, and then we'll try aborting at 14, 12, 10 and 8. Now we know these ones down here should work, but we'll just retest them anyway. So, power on, prime the sequencer, and then we'll just clock through. So again, on, off, on, off, on, off, 7, 8, 9, 10, 11, 12. The next press now it should transfer up to here, which it does. 14, 15, 16, 17, 18, 19, 20, 21, 22 and the final one 23. and if I let go now it should start again at the bottom. So that's basically now a full 24 stage sequencer. So that'll basically give us all the pulses we'll need for the branching instructions. So the question now then is, will the aborting work? So just as before, we need to get through to stage 3. At that point we can set the abort signal. So I'm going to set abort 14, and that sets the switch up there. You can see that's now been held on down there as well. So now if I click through, we're expecting to get to 14, and then the next time I release the button now that should hit 14 and start the sequence again at the bottom, which it does, and then you can see the sequence starts again. So again, all the way up to 14 and back down again. So you can do the same for the next one, which is the 12. And 8. Cool. So there I was working as it should be. So the next thing now is to check the pulses. So again, I've got this picture up here, but what I'll do is I'll do a blown up version so you can follow along. What I'll do is try and highlight which ones, which stage of the clock we're at. So first of all then, if I go to the first clock signal, which is C just A, if I let go we should get A and B, and then press again we should just go back to A again, and that basically gives us the first shape. Straight away afterwards then we go on to E, then we should get C and D, join that, then D should go off, and then C and E should go off. Great, and that brings us into this period here. So next we should expect G, F and J to come on, which they do. Next one should just leave F, J and K, and then F should go off and K should go off, leaving J, and then we get the next period will then bring on H and I, and then I will drop off, leaving H. Now at this point we've got H on, we've also got L and M on, so if I press one more time we should just be left with L, which we are, and then we get another pause period. So we're now at this stripe here, so the next one now should be N should come on, so we want N on for 3 clicks and O for 1 click in the middle of that. So N comes on, joined by O goes off, N goes off. Next one then is a Q and R. So we get Q and R on together, and then R should drop off, leaving Q, and then we get another empty period. And the final one then is S and T, and then T will drop off, leaving S, and then that's it, we're back to the start again. So effectively that's covered all the pulses you can see on the sheet here, and that's basically everything we should need, well actually everything we should need to do all of the functions of the computer. So basically the various shapes of these, we've got the ones where you have a something that covers 3 ticks and there's a pulse in the middle, like the N and O, the J and K, the A and Bs. You've got the other ones then that basically start like Q and R and S and T, where you've got both on and then one drops off. And then the only oddity one there's probably C, D and E, which is sort of a mixture of the 3 of them. And the idea for these is basically just where some of the buses need to stabilise, the value needs to come to the bus and stabilise for a while before you can use it elsewhere. And same for then going off again, so they're the ones that look like J, K, N and O. But the ones then that are a bit more easy to work on, where you can just bring the signal on and it will stabilise within that clock period, so like in Q and R, you can then take R off and then take Q off. And the reason for leaving the Q on a little bit longer again is so that in the same way that you want the value to stabilise when it's coming onto the bus, you want to make sure the value doesn't drop off the bus before you've got a hold of it in like a register or something like that. Anyway, that's done. So right, what I'll do is I'll give these cards a quick clean up now. I've got some, well actually it should be coming shortly by courier, but I've got some fluid to clean up the boards, some proper stuff that will do the job hopefully. So I'll give these boards a clean up, then I'll screw these together, and then basically I can put these into the computer. Okay, so we've now got the completed sequence of cards back in the computer. So you can see the upper card here and the lower card here, and as you can also see I've anointed them with the legends, which come off the old cards. but the LEDs are all in exactly the same place, so they all line up quite nicely. Right, so let's give this a test. So obviously if I've got any 8 cycle instructions in memory, the computer should operate just exactly as before. So what it should do is it should start here, count through to 8, and then go back to the start again. And while it's doing that, it'll be operating the pulsers, they'll be driving the controller to perform the operation as instructed. Now what's interesting here is in previous videos I've set all the bits on. So here I've put all the switches on at the top, and I've used that basically to almost like halt the computer. And the way that's been working is that because that represents an instruction that's not an 8 cycle, effectively the LEDs will go up through here and then get stuck at the end of 8, and that's because basically that's where it go onwards to the next later stages. Now obviously I can't do that anymore now, because actually if it's non-8 cycle instruction, it will just go all the way through to 24 and then restart again. So effectively I've got no way of actually stopping the computer anymore. But what I'll do is I'll start off by using that intentionally. So if I load all bits into the instruction register, then what we should do is we should be able to cycle manually all the way through the 24 stages. Now note that actually the controller is only going to react to the early pulses here, because at the moment it's not aware of any of the other pulses that we'll be using when we start implementing the GOTO instruction. Okay, well let's switch the computer on first. And sequencer wise nothing happens, exactly as we'd expect, until of course we reset. And at that point then you get the light come on just there to say that it's all primed, ready to go. So what we want to do is we want to load all those 1 bits into the first location in memory. So I'm just going to deposit that, and basically that'll put it into memory in the first location in memory, but it won't advance the program counter on, which means when I start stepping through this, it will load that instruction into the instruction register, and then that's the one that will tell it basically how long the instruction is. Now if that was an 8 cycle instruction, it would light up there and it would cycle through as you'd expect. In this case though, it's not going to light any of those up, and it's just going to go all the way through, because basically the controller doesn't know what its instruction type is. Right, okay, hopefully you got all that. So if I start stepping through, go through, you can see it's now loaded the all instruction out of the memory card, and then it's deposited into the instruction register. So at this point now the controller is trying to deal with the instruction, but the decoder doesn't know what type it is, so effectively the controller will just deal with it generically, it won't know exactly what to do. So if I start stepping through, normally at this point this is where the abort light will be set, but actually it's not set because, again, as we said, we don't know what type of instruction this is, and the program counter is now advanced, will advance shortly to the next location in memory. So that's all the fetch increment cycle. So if I click step through again, you'll now see it's loaded the program counter with the next location in memory. And that happens regardless of the instruction. All the instructions always have this fetch increment cycle to step through to the next instruction. So from this point onwards, nothing should happen other than this just cycle all the way through. So if we step that through, should go all the way up to 24, and back to the first one, ready for the next instruction. Now I've no idea what instruction is going to be in memory next, because it will just be something random, because that's how the memory works from power on. So if I step through, so we can see actually now it's found a set AB instruction, which means when I step through again, you can now see at this point now the light is lit and it's starting to do that instruction. So it's doing the immediate to bus, and if I carry on stepping through, and then move on to the next instruction, which just happens to be move 8. So okay, that's an 8 cycle instruction. This time it's a unknown instruction. So if I step through now, we'll be going all the way up to 24. So effectively that's a sequence of doing exactly what it needs to do. What's interesting here is that the controller will now need to be changed so that it can actually take advantage of all those pulses that are coming through, and we'll also need to update the decoder so we can decide what class of instruction it is. So with those two things together, we should have everything we need then to be able to start doing our GOTO instruction. Okay, well that's pretty much it this time. So I'll just leave you with the computer running, because now it will just run forever until you turn the power off.